So the first thing that you have to understand is that the sine, okay, and I know it looks like sin, but technically it's sine, S-I-N-E, okay, but on your calculator it says just simply S-I-N, and the cosine, okay, which we just abbreviate COS as cos, okay, ratios are trigonomic ratios for the acute angles that involve the lengths of the legs and a hypotenuse. So we are going to be using all three sides today when we do our trig ratios. As opposed to yesterday, we didn't use the hypotenuse for tangent, we only used the legs. All right, couple of phrases to be aware of. Angle of elevation. We refer to this as our line of sight, and that's why it looks like a little eyeball there. Okay, it's your line of sight up, okay, angle of elevation. So, for example, if I am looking at an airplane in the sky, I am looking up at the airplane, so that's my line of sight, or my line of sight is straight across, but my angle of elevation is up to the airplane, okay? If I'm looking at the top of a tree, maybe there's a cardinal sitting at the top of the tree and I'm looking at it, okay? My angle of elevation to the top of the tree, I'm looking up, okay? If I'm looking up a cliff, okay, then I'm looking up. That's your angle of elevation. Angle of depression, think depression down, okay? That's your line of sight, okay, downward. So, for example, maybe to put a little, if I am standing on a cliff, okay, and at the bottom of the cliff, there's water, and there's a little boat in the water, okay, and my friend is in the boat, okay? So, my line of sight is straight out, but when I look down at my friend in the boat to wave to them, my angle of depression is down, okay? So, it's your line of sight down to what you're looking at, okay? Now, my friend who's in the boat, their line of sight is straight out, and then they're looking up at me to wave back, so they have an angle of elevation. So this one is an angle of elevation, this is an angle of depression. Now, both of our line of sights are horizontal. So, what can you tell me about the angle of elevation and the angle of depression based upon what we learned in chapter 3? Go ahead.
Alternate interior.
They're alternate interior angles. Excellent. Okay, which means that they are congruent to each other. Very good. Okay, so understand that. So angle of elevation, angle of depression. Depression down, D down, elevation is up. Okay, think elevators go up. Okay, all right, we're going to come across that when we get to our word problems. All right, next. I gave you a little prelude to this yesterday, and I did that on purpose so that, we're familiar with it, and it's the second time seeing it. I talked about this thing down at the bottom, SOHCAHTOA, okay? That means that the sine of an angle, theta just means any angle measure, is equal to the opposite over the hypotenuse. So is SOH. Cosine of an angle is equal to the adjacent over the hypotenuse. So the CAH. And then the tangent, which we learned yesterday, of an angle is equal to the opposite over the adjacent. That's your TOA. T-O-A. Okay? So SOHCAHTOA, SOHCAHTOA, go SOHCAHTOA in the tuba, okay? SOHCAHTOA, all right? All right? No, we only use that to just kind of help us remember the trig functions. Remember, the first letter is your trig function, sine, cosine, tangent. The middle letter is your numerator. The third letter is your denominator. Okay? So it's written out again here that the sine is equal to the length of the leg of the opposite over the hypotenuse. Cosine is equal to the length of the adjacent over the hypotenuse. Okay? Questions there? Not much writing there. It's just making sure we understand the difference between sine and cosine. All right, so let's practice this, okay? All right, when you do this, you start by just choosing one of the two acute angles. Remember yesterday we talked about we don't use the right angle. So let's say we start with angle R, okay? So based upon where angle R is, label your sides as opposite, adjacent, and hypotenuse. So which one's which? 25 is the opposite. Keep going. 60 is the adjacent. The hypotenuse. Okay? So sine, which is opposite over hypotenuse, in our case is going to be 25 over 65. Cosine, which is the adjacent over the hypotenuse, is going to be 60 over 65. Okay? And then Destiny asked about simplifying. Let's simplify these to 5 and 13, and then 12 and 13. All right? Questions there? I'm not writing them down. Any questions? Understanding Soka and Toa? All right, so then all I'm going to do is I'm going to erase this and I'm going to start all over again. But this time I'm going to be talking about S. So now label our sides again. Which ones are opposite, adjacent, and hypotenuse? Yeah.
The hypotenuse stays the same.
The hypotenuse stays 65. Very good.
And 60 is the opposite.
60 is now the opposite. Now is the adjacent. So sine of S, which is still opposite over hypotenuse, now becomes 60 over 65, or 12 over 13. And then cosine of S, which is adjacent over hypotenuse, becomes a 25 over 65, or if we simplify, 5 over 13. Okay? All right, what do you notice? Very good. They're the same thing, but changed around. As in, the sine of R and the cosine of S are the same thing. The cosine of R and the sine of S are the same thing. And the reason they changed around is because, remember, when we switched angles, the opposite and the adjacent changed around. Okay, so it makes perfect sense. All right? So notice the other thing, too, is that your denominator on all of our sines and cosines are always the same number. And the reason is it's always the hypotenuse. That's why. Okay, whereas tangent, it can change depending on which one's the opposite or adjacent. All right, you try. Try example number 1. Sine of B. 24 over 25 is correct because it's 48 over 50 divided by 2. Keep going. 7 over 25, 14 divided by 50 divided by 2. 7 over 25, it's the same as cosine of B. 24 over 25. All right, so notice 25 is the denominator for all of them. That's the way it should be, okay? And then second, notice that these two are the same and then these two are the same, okay? That's a tiny little check for you, all right? So, big idea, all right? Again, in terms of discussion, it says remember always using the acute angles, make these ratios not the right angle. We talked about that yesterday, about how we're not doing that, okay? All right, next. Calculators out. Calculators out. We need them. If at any point you lent out your calculator between yesterday and today, hit mode and double check that it's in degrees. If you didn't, then you should be fine. You should still be in degrees, okay? If we go through any of these, then just, you know, and you get a different answer, first thing I would do is check your mode. All right, so what we're going to do is we are going to set up a trig function, okay, and we're going to use it in order to solve for the missing side length, okay? All right, so right away, first thing that I always do, based upon our angle measure, 40 degrees. I label my sides as opposite, adjacent, hypotenuse. So what's the W? What's the 28?
The 28 side.
Okay, good. What's the W? Opposite, okay? So the first thing that I always do is step 1, okay, is I label sides, your opposite, adjacent, hypotenuse, okay? Step 2, okay, is determine which trig function to use. Okay, and how do we do that? Well, remember that we're choosing between sine, cosine, and tangent. We look at O and H. Which trig function uses O and H? Sine. So, ka, toa. So if you need to, reminder, so, ka, toa. So the one that uses O and H is sine. Okay, so when we go to write our trig function, we're going to write sine of 40 degrees is equal to the opposite, W, over the hypotenuse, 28. Questions on that? Basically comes down to cross multiply. So like yesterday, write this over 1. W times 1 is W. And then 28 sine 40 on your calculator. 28 sine 40. Type that in. Tell me what you get. All right, so we're getting 17.99, which is 18.0 if we round. Katie, do the work?
Yeah.
Yeah. All right, so going through the directions again for this one, okay? So the first thing I do is, based upon this angle, I label my sides. So 73 is opposite, adjacent, hypotenuse. Y is opposite, adjacent, hypotenuse. What do we label this? Go ahead.
This, the 73 is the adjacent,
Okay.
and then the Y is the hypotenuse.
All right. So that's step number 1. Now I figure out what trig function uses A and H. So think, so, ka, toa. Which one has A and H in it? Ka. So what's the C stand for? Cosine. So I'm going to do cosine of 17 degrees is equal to the adjacent, 73, over the hypotenuse, Y. Doing okay?
Yeah.
Cross multiply. 73 times 1 is 73. Y cosine 14. How do I get the Y by itself? Yeah.
Divide by cosine.
Divide by cos 17. Divide by cos 17. That cancels the cos, leaving the Y all by itself. So you're going to type in 73 divided by cos 17. Really no difference here, okay? On this, we're still doing the same thing, okay? We're just solving for x. They're just giving it to you in the form of, a different type of picture, okay? So, big idea that it's asking down at the bottom is to check for your understanding in terms of angle of elevation, okay? So, or angle of depression. Here's my line of sight, and the angle is going up. Is that an angle of elevation or depression? Elevation. Number 3, here's my line of sight, okay? If I was standing at the top of this, or I was in the cart at the top, and then I'm looking down to where I'm going to be going on the roller coaster. Is that an angle of elevation or depression? Depression, okay? So just remember, elevation is up, depression is down. All right, now that doesn't affect how we're going to solve, because we're still going to do the same thing. We're going to label opposite, adjacent, hypotenuse. So based upon the 62 degrees, 50 is the adjacent, x is the hypotenuse. What trig function uses A and H? cos. So cosine of 62 equals the adjacent 50 over the hypotenuse x. Cross multiply. 50 equals x cos 62. What do I do with the cos 62? Divide. Divide. So we're going to type in 50 divided by cos 62. Notice that we are solving for the hypotenuse, which means that we should get a number greater than 50. 106.5, I heard. Anybody not getting that from typing it in? You should practice typing it in. All right? Number 3. Try this one on your own or with people at your table. See what you get. All right, so it looks like people are getting 143.95, the 5 rounds. So 144.0 is better. Okay? All right, we're going to do one last one together. Okay, and I'll probably just focus on setting it up. And that's number 4. All right, there are going to be times when they have all 3 sides labeled. Okay, so here's how you essentially do it. Okay, it's not that hard. We are basically going to start out by ignoring the y. Okay, as if it's not even there. See, I erased it. It's gone. So I'm going to label the x. And what am I going to label the x as? Opposite, adjacent, or hypotenuse? Opposite. I'm going to label the 20. H for hypotenuse. What trig function am I going to use? Sine. So sine of 35 degrees is equal to x, the opposite, over the hypotenuse 20. So I don't label all 3 sides, or you can, I guess. Okay? But now when I go to solve for y, now I need the y value back in there. What do I label the y as? Opposite, adjacent, or hypotenuse? Adjacent. And then always use the number that they give you. So I'm going to still use the 20, the h, and I'm going to use the y. So what trig function uses a and h? Cos. So I'm going to do cosine of 35 degrees is equal to my y value over 20. Okay? So basically all I'm just trying to show there is just focus on doing one at a time. Okay? And then in both cases, when you cross multiply, you're going to get x is equal to 20 sine 35. And you're going to multiply over here and you're going to get y equals 20 cosine 35. What's x equal to? Anybody get it? 11.4. Anybody get cosine? 11 point.
It's 0.47.
Oh, so this should be 0.5. Okay. Anybody get the cosine? Should be bigger than 11.5. 16.4. Okay.